Richard Dean Meininger had a notable career as an engineer, particularly known for his work in the field of electronic design and software development. He played a significant role in the development of circuit characterization and diagnostic systems, contributing to innovations that improved engineering processes. His expertise in this area was further exemplified during his time at Pentec, where he first used his design, the electrical circuit characterization and diagnostic system, or ECAD. This system was significant for its time and aimed at enhancing the efficiency of electronic design processes. He then founded his own company called Char Services Inc., where he further developed this technology. The electrical circuit characterization and diagnostic system, or ECAD, is a system used for analyzing, diagnosing, and characterizing the electrical properties and behavior of circuits. Key components and functions. Characterization, measurement and analysis. ECAD systems measure various electrical parameters such as voltage, current, impedance, and frequency response. This data helps in understanding the normal operating characteristics of the circuit. Modeling. The system can create models of the circuit based on the measured data, which can be used to predict behavior under different conditions. Diagnostics, fault detection, and isolation. The system can detect and identify faults, such as short circuits, open circuits, or component failures, by comparing the measured data against expected values. Root cause analysis. It provides insights into the root causes of failures, allowing for more effective maintenance and repair. Testing. Functional testing. ECAD systems can simulate different operating conditions to test the functionality of the circuit. Stress testing. It can also apply various stress conditions, such as over voltage or over current, to assess the robustness of the circuit. Monitoring. Real-time monitoring. ECAD systems often include real-time monitoring capabilities to track the performance and health of the circuit during operation. Data logging. They can log data over time for further analysis, helping to identify trends or intermittent issues. Applications. Manufacturing. To test and validate circuits during production, maintenance and repair. To diagnose and troubleshoot issues in the field or during routine maintenance. Research and development. For characterizing new circuit designs and ensuring they meet specifications. Benefits: improved reliability. Early detection of issues prevents unexpected failures. Efficiency. Accurate diagnostics reduce the time needed for troubleshooting and repair. Quality control. Ensures that circuits meet required specifications before deployment. Overall, ECAD systems play a crucial role in ensuring the reliability and performance of electrical circuits in various applications, from consumer electronics to industrial automation. For over 30 years, Char Services has been providing cable testing and EMI RFI troubleshooting services to support the health and maintenance of cable circuits in nuclear facilities. The cable condition monitoring system measures the health and integrity of a cable by performing a series of non-destructive electrical tests that can be administered from the measurement end of the cable circuit. This allows testing of most cable circuits and end devices while saving test personnel exposure to potentially harsh environments. The data collection is managed by user-friendly proprietary software that automatically trends recent measurements with historical baseline data, while flagging discrepancies and outliers. The Char system performs a comprehensive set of measurements to help identify and locate impedance problems, moisture intrusion, shorts, shunts, and open circuits along a cable, in connectors, and at end devices. For example, neutron detectors can develop problems in their cables and connectors or within the detector itself. These problems result in erroneous flux indications or false neutron count readings. The Char system can identify the location and nature of the problem and guide the plant as to whether the problem is in the neutron detector itself or along its cables or in its connectors. Nuclear Instrumentation Testing Program. Nuclear instrumentation (NI) systems in nuclear power plants often suffer from electrical noise issues that can cause plant scrams or threaten on-time startups. To address this, Char Services has developed an NI testing program for source range monitors, intermediate range monitors, and local power range monitors, SRMs, IRMs, LPRMs, in BWRs, and X-core nuclear instrumentation in PWRs to help identify NI circuit problems prior to any operability impacts. The Care Services approach employs periodic health checks made through electrical measurements of each detector and its cable and connector properties. These measurements are performed remotely from the control room area using Char's cable characterization system, CARE. This integrated test unit has been used in numerous nuclear power plants over the last 30 years to both identify and determine the precise location of problems in NI circuits. Program objectives: reduction of lost generation from SRM and IRM related issues, establish baseline data to streamline future troubleshooting, automate LPRM current voltage testing to improve outage duration, restore bypassed LPRMs to service, reduce reactivity management events, IRM data showing location of noise coupling, RTDR data, IRM data showing location of impedance change, TDR data showing extraneous noise with SRM, comprehensive LPRM testing for metal whisker burning and signal integrity problems. A common preventative maintenance activity for BWRs is to perform electrical tests such as current voltage measurements of LPRMs during the outage, as most BWRs have between 125 and 175 LPRMs. This testing activity can take up valuable I&C resources and at times can become a critical path activity. Care Services offers comprehensive LPRM testing services to automate this testing activity. By integrating multiplexers with multiple care systems, LPRM IV testing can be performed on nearly 80 detectors at a time, while also providing complete electrical characterization of each detector through performance of TDR, IR, and DC resistance measurements. This automated service significantly reduces LPRM testing time, allowing all detectors to be tested in approximately one shift. In addition to automating the testing process, Care Services also has unique capabilities to resolve any problems that are identified. For example, a typical failure mechanism for LPRMs is metal whisker growth between the plates of the detector. These whiskers can short circuit the LPRM detector, which must then be placed in bypass mode. Each plant must have a certain percentage of LPRMs operational to remain online. Care Services offers comprehensive LPRM testing services to rejuvenate LPRMs by burning the metal whiskers in the detector using the Care Cable Characterization System. The Care System Enhanced LPRM IV allows up to 60 milliamps of current to flow to the detector during an IV curve spiking event for improved metal whisker burn. If a poor IV curve is observed during high-speed LPRM testing using the Care System, Care Services will then follow up with the EEL test system to help heal the detector. The EEL test system can also be used to target bypassed or malfunctioning detectors, allowing plants to avoid expensive detector replacement. Plant life extension cable testing. The majority of nuclear power plants in the United States have been granted licenses to continue operating past their initial 40-year period. Now, many nuclear power plants are considering a subsequent license renewal that will allow them to operate for up to 80 years. The Nuclear Regulatory Commission has established guidance for nuclear plant license renewal in NURIG 1801 and NURIG 2191 that includes information for site cable aging management plans to enable long-term operation. In support of these aging management plans, Care Services has developed a comprehensive plant life extension testing program to help nuclear plants meet NRC requirements and also obtain the most comprehensive information possible about the health of cables, connectors, and end devices. Care Services. Plex testing satisfies license renewal commitments and identifies any degradation in the cable circuit that could impact plant performance now or in the future. Plex testing also establishes baseline data for trending and monitoring purposes, which can be crucial when troubleshooting future cable problems and helps avoid premature replacement of components. The Care Services approach to plex testing includes a wide variety of cable testing techniques to characterize the bulk health of the cable, connectors, and end device. The acquired data is then compared to acceptance criteria Care Services has developed using existing industry guidance, 10 years of laboratory research and development, and 30 years of testing within the nuclear fleet. As an example, for cables used in high voltage, low-level current signal applications such as nuclear instrumentation, the XIE2 Aging Management Program applies. To satisfy XIE2 requirements, Care Services has developed a plex testing methodology specific to nuclear instrumentation to objectively address this program requirement and support long-term operation of nuclear instrumentation circuits, cable aging and condition monitoring. Care Services offers a cable testing and cable aging management program designed to meet the routine cable troubleshooting needs of the nuclear industry and address the regulatory and industry concerns with cable aging related to plant life extension or license renewal. The program involves a number of electrical and mechanical measurements to identify and resolve connectivity issues in conductors, connectors, and end devices, and to assess the condition of cable insulation material. A cable is simply made of a conductor wrapped in one or more layers of insulation material. While testing conductors, connectors, and end devices is performed in response to specific operational problems, cable condition monitoring is performed to identify degradation in cable insulation material and for cable aging assessment and remaining useful life prediction. Cable condition monitoring is of particular concern in nuclear power plants seeking license renewal to operate up to 60, 80, or more years. Care Services provides equipment, training, and services for electrical testing of conductors, connectors, and end devices, and troubleshooting to resolve indication issues or equipment performance problems. They also supply electrical and mechanical test equipment to determine the condition of cable insulation material